All right, well, welcome to your 13.3 part 2 video. Today we're going to be focusing on the unit circle. Now, to set this up, if you remember in 13.3 part 1, we talked about what if there were angles that started here and went somewhere bigger than 90 degrees. And we talked about how are we going to find the sine, cosine, tangent of that angle. Well, the unit circle is a way to kind of regulate that, and it's going to do something really nice for us, and then it's going to help us memorize the sine, cosine, tangent of all of these angles all the way around the circle, no matter how big. So, with that being said, let's first introduce what the unit circle is. So I have some facts up here. I'll be filling them in throughout the video. The first thing we need to know about the unit circle is that the radius is 1. That's why they call it a unit circle, because the radius is 1. It is a unit, 1 unit. Okay, so each of these radii, from here to here, this is 1. From here to here, this is 1. From here to here, this is 1. Now, I have different lines drawn in here to represent the different angles. And for now, we're just going to worry about quadrant 1. But let me just tell you, this is the 0 degree angle. Or like if you think about it being the whole way around, it's the 360 degree angle. Okay, so there's that. The next one is the 30 degree angle. The next one's the 45 degree. The next one's 60 degree. And the next one is 90 degree. And these are things that should make a whole lot of sense. Notice that I'm choosing the angles off that chart that I made you memorize. So what we want to do next is we want to think about what x and y coordinate is this point right on the border. What x and y coordinate is this point? What x and y coordinate is this point? We already know what x and y coordinate this point is, isn't it over 1 up 0? We also know what x and y coordinate this is, isn't it over 0 up 1? Again, because here's the origin, and this is a radius of 1, so it's just, yeah, over 0 up 1. But in order to find what these are, I'm going to make use of special triangles. So let me show you how. First of all, let's just remind ourselves what our different special triangles are. We have our 30, 60, 90. We have our 45, 45, 90. And then here I just wrote the 60, 30, 90 the other way around. Because here's what we can do. If I figure out what these sides should equal, can't I take this 30, 60, 90 triangle and put it right here? See what I'm doing? Like, I can take this triangle and stick it right in at the 30 degree angle. This is a 30, 60, 90 triangle. And that should help me figure out what the point is, okay? So let's think about what the ratios are here. Now, we know that ratio-wise, this side is x, this side is 2x, this side is x root 3, and you should just have that memorized. Even if you don't, we know that we can use trig to find this. We can even use our calculator. Anyway, the point is, in the unit circle, which side do I already know? Remember, the unit circle has a radius of 1. So I know that this side needs to be 1. So does it make sense that if these are in a ratio of 2x, x, and x root 3, that the x has to be 1/2? Does that make sense? Because if I need this side to be 1, and this side is 2x, well, 2 times 1/2 is what gives me the 1. So this side, the 2x side, is 1, and that helped me figure out that the x should be 1/2. So this side needs to be 1/2. This side, I guess, is 1/2 root 3, or I can write it as root 3 over 2. Okay, so here's our 30, 60, 90 degree triangle that I'm going to be able to fit into the unit circle. And again, you should know how 30, 60, 90 degree triangles work. I just figured out that since the radius of the circle is 1, which matches with the hypotenuse here, that told me how to scale the other sides. So let's actually go ahead and label our 30, 60, 90 triangle in our unit circle. This side going up is 1/2, and this side going horizontally is root 3 over 2. So think about how that helps us label the point. I'm going over 3.2, sorry, what am I saying? Over root 3 over 2 and up 1/2 to get to that point. So because I went over root 3 over 2 up 1/2, that's exactly what a point is. So root 3 over 2, 1/2, okay? Now, we should be able to do the same thing if we flip the triangle sideways because I have a 60-degree angle. So what if we flip the triangle sideways? Now my angle is 60 degrees here, 30 degrees here, and a right angle here. So let's just go back down here. My hypotenuse, as always, is 1. But now instead of the 1/2 being over here, it's over here. I'm just flipping the triangle sideways. So that means I'm going over 1/2 up root 3 over 2. And that's how I'll fill in the point. Over 1/2 up root 3 over 2. Okay, nice. Now, in order to find the 45-degree angle, we need to put in the 45, 45, 90. So 45, 45, 90, here it is. This is 45 degrees. This is 45 degrees. Again, I know the radius is 1. That's the whole point of a unit circle. Now, I know the ratio is x root 2. So if this side needs to be 1, let's think about that. I need the x root 2 side to equal 1. So in order to find what x isn't x 1 over root 2 if I divide both sides by root 2? So I just solved the equation. I knew that x root 2 had to equal 1, and if I divide by root 2 to cancel, that tells me that x has to equal 1 over root 2. Okay, so this side is 1, and I now know that x has to equal 1 over root 2, so each of these sides is going to be 1 over root 2, except instead of writing 1 over root 2, let's write the form where the square root is off the bottom, root 2 over 2. Hey, there was a brief cameo appearance by some students wanting to drop off their backpacks. So, okay, yeah, we're going to use the root 2 over 2 because that's the more proper form. So, when we stick our 45, 45, 90 triangle, we now know that it's over root 2 over 2, up root 2 over 2, and again, that's how I'm going to label the point. Now, what's the point of all this? It's super nice that I know these different things. Yay, I know what these angles are, I know what these points are, but who cares, right? Well, here's the deal. This relates to trig somehow. Let's see if we can make the connection. Let's see what the sine, cosine, and tangent of 30 degrees is. So if I do sine of 30 degrees, let's see, that's opposite over hypotenuse. Well, since it's 1/2 over 1, isn't that just the same as 1/2, right? Like if I'm dividing by 1. Okay, what's cosine of 30 degrees? Well, that would be the adjacent over the hypotenuse. And again, since it's root 3 over 2 over 1, that's the same as root 3 over 2. Where do I see these numbers up here in the point? It looks like the cosine is corresponding with the x value, and it looks like the sine is corresponding with the y value. Let's see if that makes sense with another right triangle. Let's look at the 45, 45, 90 triangle. So here, the sine of 45 degrees is equal to, okay, it would be the opposite over the hypotenuse. Well, that's just root 2 over 1. But again, that's just root 2 over 2. Is that the y value? It is. It's also the x value, but that's coincidence. Since this side is the same as this side, the cosine adjacent over hypotenuse is also going to be root 2 over 2. So here's the deal with the unit circle. Here's what's really, really amazing about it. If I can just figure out the points that are around the unit circle, it will tell me the sine and the cosine. So what we just learned is that the sine corresponds with the y value. Let me put that up in my facts. The sine corresponds with the y value. The cosine corresponds with the x value. And let's see if we can figure out what the tangent corresponds to. And then we'll call it a day. And we'll fill out the rest of it in class using some other cool right triangle properties. So the tangent, all right, let's see. Tangent is, I think that's opposite over adjacent. So opposite over adjacent. Isn't that just dividing x by y, right? Y over x. So we said the cosine was x, we said the sine was y. Let's see if that works here as well. Here for the 45-degree angle, this is getting a little cluttered. Am I still making sense? I don't know. The tangent of 45 is opposite over adjacent. This is root 2 over 2 over root 2 over 2. This is still, I know it's hard to see because they're both the same, this is still the x over the y. So for the tangent, y over x. So tangent is y over x because it's opposite over adjacent. The opposite is x, the adjacent is y, or the other way around. I'm making little sense right now. Anyway, we'll fill in the tangents in class as well. What does the tangent equal here? What does the tangent equal here? We'll be able to find that out with y over x. Okay, so that's where I'll leave you, and I'll cut it off here so that the video doesn't get too long. But the amazing thing we learned is that if we stick these right triangles with a hypotenuse of 1 into our unit circle with a radius of 1, it helps us find these points. But these points then help us find sine, cosine, and tangent. So there's your introduction. We'll talk more about the unit circle in class. See you then.